Hello everyone, in this video I'm going to perform k-means clustering using R. For this exercise we are going to use candy bars dataset. First we need to set our working directory. And next we are going to import the candy bars data into a data frame and then label it my data. So here we are going to type my data is equal to read.csv candybars.csv. Control Enter. Now you can see my data under Environments pane. Next we are going to install cluster packages. Install.packages cluster. I have already installed these packages. If you have not, please click Control Enter and then you first need to install this package. And now I'm going to deactivate this line. And next I'm going to use library to activate this cluster package. First, let's briefly look at the dataset. Here on the screen you see candy bars dataset. So what you want to do is you want to cluster these candy bars based on their nutritional components. And you see for each brand you have calories, fat, protein and carb. In order to cluster these candy bars we are going to use k-means cluster. And in this data set, as you see, we are going to exclude the brand column and focus on the remaining columns. So to exclude the brand column, we are going to select columns 2 to 5 from my data frame. And we need to also standardize the other variables by using a scale function. So here standardize the variables. And I'm going to call this new data frame my data1 is equal to scale. And I'm going to choose from my data all rows but 2 to 5 and then Control Enter. Now you have a new data frame here on the Environments pane. Next we are going to use setSeed function to set the random seed. So let's type it here, set.seed1 and Control Enter. And then we will use PEM function to perform the k-means clustering. Within the PEM function we set the option k is equal to 4 to have 4 clusters. And we store the clustering results in a variable called k-results. So let's type it here, k-results is where we store our results, and PEM function to perform k-means clustering. And we are using my data1, k is equal to 4. Now you have k-results on the Environments pane. In order to see the results, let's type here summary. We are going to use summary function. And then Control Enter. Under console pane, you are going to see the results from clustering. So in order to visually see the clusters and their members, we are going to use plot function. Visualize the results. So we will use plot function and k-results. Control Enter. So you need to follow the prompts here. First click here. And then click Enter. Now on the plots pane you have the clusters that R produces. If you click here and enter the second time you will see silhouette plots. Now let's first look at these clusters. So the cluster plot that you see on the screen incorporates principal component analysis to summarize information from the 4 variables: calories, fat, protein and carb. Because we cannot plot a 4-dimensional graph based on the 4 variables, we use PCA in order to plot the clusters onto a 2-dimensional graph with the first 2 principal components as the x and y axis. These principal components, if you remember the principal component analysis, explain the highest degree of variability in the data. In this case, the first 2 principal components explain 88.75% of the variability. Each of this green oval represents a cluster and the observations in each cluster are displayed using a different marker. So here there is one cluster and there is triangle. Here there is another cluster and these are circles. And here another cluster and you have plus sign, and here you have multiplication sign. And if you click here and enter, you will see silhouette plot. And this plot shows how close each observation in one cluster is to observations in the other cluster. It also allows us to visually determine the appropriate number of clusters. The silhouette width for each observation, SI, ranges from -1 to +1, where a value closer to 1 indicates that the observation is well matched to its own cluster and poorly matched to neighboring clusters. If most observations have values close to 1, then the clustering configuration is appropriate. If many points have a low or negative value, then the clustering configuration may have too many or too few clusters. So the results that you see on this figure seem to suggest that the results are good, but not great. Clusters 2 and 4 seem well configured. 2 of the observations in cluster 1 and 1 observation in cluster 3 have silhouette widths that are negative. The average silhouette width is 0.32, suggesting a reasonable clustering configuration overall. It is not clear if a different configuration would necessarily improve the results. So this is how you perform k-means clustering in R. Thank you for watching this video.